This slide deck is just to tell you what tools are going to be available for you to use. So you know what exists before trying to use it. It's like before you can start learning how to spell words, you have to learn the alphabet. You have to learn what letters are and how you can put letters together. But letters aren't that complex, right? They have a glyph and they have an utterance, and then everything else is other rules built on top of it. Okay, so here we're going to talk about the Unix programming tools. It's based off a PDF, a very short PDF. It's only 16 pages, and we're just kind of run through dissection. In fact, a quick overview. We're going to introduce what are Unix tools. We're going to divide this into 5 sections: the GCC compiler linker, the make project utility, the GDB debugger, the Emacs editor, and the Unix shell command. The motivating topic on this particular PDF, though, is you have all these built-in tools at the systems level inside the command line so that we never have to escape out of it. There's no GUI application that we're reliant on to be able to do any systems level development or coding or executing, right? Or compiling or anything in between, or debugging, right? And the value of this is you're not always given access to a headed server or operating system. You might not have, and when I say that, you might not have something that gives you windowing capabilities. And in that, if that's the case, if you're going to remote in, if you're going to SSH into a server, the tools that you can depend on are going to be these. So you should learn how to use these, right? Because you're guaranteed to have access to them. And then if there's other tools you like better than that, you can use these to install them so you can use your other tools. Okay. So this is pretty much just me talking. So really, by going through this, we're going to learn effectively the overall idea that there's this edit, compile, link, debug programming cycle. You're probably already familiar with that cycle. Here we're going to examine it from essentially systems level applications. Okay, so let's talk about our compile process. Here's a long, verbose explanation. I'm not going to spend too much time talking about this explanation. I'm going to kind of just go through the visualization, which was motivated by that explanation. So here we said you might have your C code. We haven't written a lot of C yet, so we'll just believe that this is the case, right? We have a main.c, a module1.c, a module2.c C files. We can go through the act of compiling those. When we compile those become object files. Then once we have those object files, so main.o, module.1, which is effectively just our compiled code, then we can link those together. And once they're linked together, then it's a complete program. So the idea about going from source code to something that's executable has a compilation step and then a linking step. Okay, so what are we going to use as our compiler linker? It's going to be GCC. Why? It's up to date, it's reliable, it's available on almost every platform, it's open source. We can use it for C or C++, even Objective-C. Yeah, I mean, that's pretty much all the good reasons to use something. And in fact, if you're using almost C in any other class, like if you're going to take graphics, you'll be using GCC compiler as well. So the GCC is both a compiler and a linker. It will compile our code into our object files, and then it would link those object files into the application so that we can actually execute it. So we can either do it all in one go. This first example we see on GCC, where we're going to give it multiple C files. In this instance, it's main.c, module1.c, and module2.c. And then I'm going to go ahead and output that to be this program here. And so that's going to compile those and then link them to then become that executable program. Okay, or I could do it individually. I can just go through the compile steps. So GCC for just compile the one file, the other file, and then once I have all my object files, then I can call on GCC to go ahead and link those into the program. Yeah, of course. That you've already motivated section 2, make. Okay, anyway, general form of GCC is you have your options, your various flags you can apply, and then the files that you're going to point to in terms of what you're going to be reading to compile those. And you have lots of really common command line options, but again, this is just to let you know how we're going to be compiling our C code. So just like you learned how to use the JDK and the JVM to be able to compile your Java and how to run it, similar concept. Now, in terms of how to use it, see this primer, and it gives much more details. It's outside of the confines, the scope of these slides. Okay, let's go to what was motivated over here. Make. What is make? Well, typing out, as you could probably be aware, typing out these GCC commands for a project gets difficult as the project grows to be bigger and bigger and bigger. And in fact, that's true with Java too. Java is a pain in the rear for big projects. And so they have things like Maven, right, which are these build tools that allow you to take really complex Java projects and define a configuration on like a config file that says how to build them. Well, that concept of a build tool is what Make is. It allows us, it's a utility that automates the process of compiling and linking for us. So it allows us to say, for instance, and so everything that we're learning about in terms of things like our debuggers, in terms of like our make tools, we can actually access through Emacs or text editor as well. I'm going to kind of ignore that. I'm just saying that it kind of seamlessly integrates with a lot of these other utilities. Okay. So so in order for a make to occur, it relies on a make file. That's our configuration file where we can go ahead and define things like variables, like directory names and whatnot, that we can then dereference inside of or use inside the make file. And then when we use make parses the make file and then executes the compilation and linking of all of our source code files into an executable file. Now, an advantage of make, in addition to that, is that it can check, you can put dependencies on there, so it checks to see if a file changed, and if it doesn't recompile it. If it does recompile it, just like Java does, in a way. So just a quick example of what variable looks like in make. CC would be the variable name. GCC would be like that keyword that make will invoke that actually triggers the compiler. So common flags that we would see inside of these variables, CC, C flags, and then the LD flags, which are going to be our compiler flags and our linker flags. So just an example of what a make file looks like would look like this. So here on this top line is going to be us creating the variable called C flags that actually has some of the user specified, your dev build specifics. And then if we use the $sign and then parentheses, allows us to effectively dereference that so that it'll actually go ahead and invoke that from our make when make gets called. So this first line is our variable. Second line, we'll use those variables. So the make file really relies on this idea of a dependency build rule, where the dependency line is a trigger which says, when do we want to do something? And then our command line specifies what to do in response to that trigger. And so the first rule is always like the default rule. So let's take a quick example of that. So this is what a dependency rule build rule might look like. So here, this top line, like I said, would be our trigger. In this instance, the dependency line says the object file binky.o must be rebuilt whenever any of the binky.c or binky.h or agbar.h change. So if any of these change, then recompile to make a new binky.o. So that's our dependency rule. And then our second rule, the command line rule, will be defining how do you rebuild. So again, this is the trigger. This is the actual actions that causes the recompilation to occur. You have to have a tab, though, in front of your command line. That's a symbol that is parsing that the make file is going to try to parse against. So you can't forget that. And you can't use spaces. It's got to be a tab. And so an example of a very complex make file is here. We won't walk through it because it's not necessarily worth it. And we can, like I said, we could do that inside of Emacs. GDB is going to be a systems level debugger tool. Debugging tools allows us to examine the contents of what's being executed by our application while it executes. Did you use debuggers while you were doing assembly? Perfect. So you're aware conceptually about what a debugger is. GDB just happens to be a debugger that's available to us by effectively GCC, right? So they intertwine very nicely. So we won't spend too much more about the debugger, except for the fact that we can launch it using GDB and then whatever the program name is. And there's various things that we can define in terms of like breakpoints or examining the stack or examining the data that you'd expect from a fully featured debugger. It's just this one we can operate right at the systems level without having to worry about external code. The other thing we want to be aware about is built-in systems level text editors. The one that gets covered in the primer document is Emacs. And because Emacs is kind of organically grown with new, right? But just as valid is VI or Vim, right? So there is definitely a culture clash between Emacs and Vim. I'm not getting in the middle of that. Yeah, it's true. And I'm not going to get into the system. Oh yeah, you always have Nano too. And so, but the nice thing about Emacs is it does kind of it fits in well. It supports a lot of these other utilities from the go. So like there'll be shortcuts you can do, keyboard shortcuts you can do. Exactly. Which is, and in fact, if you want to know what all those are, check the primer. It actually covers every use case here. And then the last thing that I want to mention inside of this slide, just so that you're aware, are probably things you've already seen, but you'll probably use a lot more this semester than you've used in prior semesters. And that's going to be all of your various shell commands, such as commands that relate to your directory commands or commands that allow you to like alias for common locations like parent directory, current directory, root directory, home directory, things like that, or different miscellaneous things like being able to inspect files or being able to kill processes or being able to search for things inside of the system, things like being able to get help through man pages or being able to inspect the history of prior commands that you put into your shell script or your bash inside of your system, or pipes where you can take data that's put out from one application and pipe it into another application. All these are covered inside the primer. Does anyone have any questions related to this? I think this covers all the primer stuff. We have we'll catch up and do the first chapter of the books next Tuesday. Excellent. And then you're gonna post links. I'm gonna post the links to the slides on Discord, to the videos on Discord. I'll try to get this video once it's done processing up on online as well. And I'll also get the labs available so that you can actually start submitting on the labs. Because at this point, you've seen C, and now you know how to access system level applications. Now we can actually start going through the contents of the book. All right, everyone have a great weekend.